Okay, here we go.
I'm not really proud of this, I don't want
Here we go, folks. Even functions. The cosine at negative t is equal to the cosine of t, and the secant at negative t is equal to the secant at t. Why? And because this is a true statement. How can they say this is a true statement? They're saying that whenever you take the cosine of the negative angle, that it's equal to the cosine of the positive angle of that. But why is this true? Because all angles have two angles. That's interesting. Okay, let's talk about the cosine of negative pi over 4. Okay? Let's talk about that. Where's the cosine at negative pi over 4? That puts me right here. Agree?
Yes.
Yes? Now, what are all the angles in quadrant 4? What do they look like? They are going to be positive, negative angles, right? The cosine is going to be positive, the sine is going to be negative. Do you agree with me on that? Now, what this is saying is that if we compare it to pi over 4, which is in the first quadrant, all angles in that quadrant, the cosine is positive and the sine is going to be positive also. Now, if we're talking about the cosine of these angles, remember whenever you're on your unit circle, we have the hands of the clock, 90, then 1, 2, 3, right? So this is going to be the square root of 2 over 2, square root of 2 over 2. That's my angle. Down here, however, I'm going to have the square root of 2 over 2, comma, negative square root of 2 over 2. Why is it negative? Because the sine is negative in quadrant 4, agree? Now what this is saying is that these two values, meaning our cosine values, should be the same. Are they? Well, yeah, they are, because in both quadrant 1 and in quadrant 4, the cosine values are always both positive, right? Which means that this would be a true statement, that if I have the cosine of a negative t being an angle, that that's going to be equal to the cosine of the positive t angle. Do we get that, yes or no? Now, if cosine is going to be an even function, that means secant is going to be an even function. Why would secant be an even function? Because they are reciprocal to one another, right? So if we have even functions, we also have odd functions. So now write down the odd functions. Odd functions are going to be your sine, which then implies cosecant, your tangent, and then your cotangent. Now, why is this all true? Well, it goes right back to the whole concept of what we just talked about the last time. Now we're going to use a different angle. Do you want to use a 30 or 60 degree angle? Okay, 60. So if we're doing the sine of negative pi over 3, negative pi over 3, where is that going to be at? Negative pi over 3 is going to be in quadrant 4. Well, what do we know about quadrant 4? We know that this is going to be the positive negative. Now, if we're talking about pi over 3, again, in quadrant 1, that's going to be plus plus, correct? And if we're talking about the hands of a clock, we're going to be at 1/2, comma, square root of 3 over 2. To make this down here, 1/2, comma, negative square root of 3 over 2. Well, what they want you to compare is going to be what here? What are we comparing? We're comparing the sine values. Look at the sine values of these two lovely little angles, pi over 3 and negative pi over 3. If you look at those sine values, what you're going to notice is that they are going to be opposite of one another. Meaning, in order for this to hold true, this is saying that the sine of negative pi over 3 is going to be equal to negative times the sine at pi over 3. What is the sine at pi over 3? The sine of pi over 3 is going to be the square root of 3 over 2, which gives me negative square root of 3 over 2. Is that a true statement? Do those equal each other? the theorem does work, okay? And it's all because it falls on where the quadrants are at. Remember I talked about with the unit circle of any quadrant one, what did you automatically know? The rest of the quadrants. Because the only thing that changes about the sine and cosine values are going to be if they are positive or if they are going to be negative. Do we all understand that, yes or no? Okay. The next thing I need to talk about is going to be the periods. Do we need to see it again? Please, folks, don't drop your pencil to noise. Just simply say, Mrs. Yoder, I'd like to look at that slide a little bit longer. Once you get quick.
I got plenty on this stuff.
So for that, would you be able to try this for the top one or bottom one?
It's proving that that's an odd function. It's showing that whenever you take the sine of a negative angle, that it is going to be equal to negative times the sine of the positive angle. Because they are in opposite quadrants. Quad 1 and quad 4. You absolutely can, but then they write it down in the theorem form for you. You can either memorize the theorem or you can say, hey, logic tells you if you just put them on a lovely little graph, you can see the difference. I think if you put it on the graph, you can see the difference. I do not memorize that stuff. If you want to, you can. Are we ready? Period. The number of units it takes to complete one graphical cycle. Now, what in the world does this mean? This means I want to know the number of units it's going to take to go around the unit circle. Well, how many units is one revolution around the unit circle? The unit circle has a radius of 1, but how many units? In other words, what's the circumference of the unit circle? The circumference of the unit circle is 6.28, which is equivalent to 2 pi. In other words, one complete cycle, one revolution is going to be 2 pi units. Well, what are we talking about? For the sine, cosine, secant, and cosecant graphs, to go one revolution around the unit circle, it is going to be 2 pi units. In other words, that 2 pi is how you're going to find the coterminal angles. That's what's helpful, okay? Tangent and cotangent have a period of being pi units. In other words, in 2 pi units, you've completed 2 cycles of the tangent and the cotangent graphs. We're going to get more into those graphs in section 4.6, but we're not going to talk about too much of that until then. The whole point of this is whenever it says use the period of it, all it's asking you to do is to use the coterminal angles. Do we understand that? Okay? Because remember whenever I told you to put your hand at 3 o'clock on your steering wheel, and I asked you to find the coterminal angle to it, what were you actually doing? Going all the way around. If I asked you to find the negative coterminal angle, all the way around, right? The opposite direction. Remember? We're going to do examples. Now, before I start with tonight's homework, we're going to go ahead and go over any questions you had over last night's homework. Last night we got as far as where? 14. So, we talked about 14 last night. Let's go on to the next section. It says evaluate if possible. Let's do problem number 17. T is equal to negative 7 pi over 4. It wants to evaluate the sine, cosine, and tangent of the real number. So I need the sine, cosine, and tangent of that. But in order for me to do that, I need to first figure out where this thing is at on the unit circle, right? I have a lot of information about it already. What's the first bit of information I should know about this thing? What's the denominator?
4.
Denominator is 4, which means I am dealing with sine and cosine values that look like this, correct? I just need to determine if it's going to be positive or negative. How do I determine if it's going to be positive or negative? It's by determining what quadrant this thing lies in, correct? So the first thing I want to do is I need to take negative 7 pi over 4, and I'm going to add 2 pi to it. Why am I adding 2 pi to this? Because I need to be able to get it on the unit circle. Right now, I don't know where negative 7 pi over 4 is at, do I? So 4 times 2 gives me 8, so negative 7 pi over 4 plus 8 pi over 4 is going to give me pi over 4. In other words, this angle is equivalent to pi over 4. Do we understand that?
What angle is?
Okay.
I wasn't seeing when you pointed.
Everyone needs to pay attention to me. This right here is going to be 0, which is also going to be 2 pi, which is also going to be 8 pi over 4. This is going to be pi, which is also going to be 4 pi over 4. Do we all agree with that? So if I have a negative angle, that means I am going to be opening up. Here's going to be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 right here is going to be my angle. Here, there it is. That is equivalent to what positive angle? It's equivalent to the positive angle of pi over 4. Well, how did I find that out mathematically without having to draw it? I added 2 pi to it to find the coterminal angle. The coterminal angle tells me exactly what quadrant I'm in. Pi over 4 is in quad 1, and in quad 1, it's the plus plus quadrant, which means this is the point that I'm using. Agree? So now can I find my sine, cosine, and tangent values? Yes. What is my sine? Sine of negative 7 pi over 4 is going to be what? Square root of 2 over 2. The cosine is going to be what? Square root of 2 over 2. And the tangent is going to be what? Sine divided by cosine, which is going to be 1. There's your answer. I'll do another one from that section. Pick one more, guys.
22.
What number? 22. Well, isn't okay.
No, that'd be good.
You're just not thinking. Guys, if I'm at 0 and I'm going to go negative 2 pi, I'm opening up this direction, a whole revolution. Negative 2 pi is the same thing as 2 pi, which is the same thing as 0, right? If your brain needs to see it this way, negative 2 pi plus 2 pi is going to give you 0. So 0 degrees. I need that point right here. That's going to be the point 1, 0. So what's my sine? Sine at negative 2 pi is going to be my y coordinate, which is going to be 0. What's my cosine? Which is going to be my x coordinate, which is going to be 1. And what's my tangent? 0 divided by 1 is 0. Okay, go to the next section. It says evaluate if possible the 6 trigonometric functions. Pick a problem out of there for 22 through 28. Pick a problem, hurry up. 26. What is that problem? T is equal to? 3 pi over 2. Okay, now what's the 6 trig function? Well, where is 3 pi over 2? Is that on my unit circle? Well, yeah, it's on my unit circle. More importantly, it's going to be the angle right here. Do we see that? So that's going to give me the point, what? 0, negative 1, and that's going to be 3 pi over 2. So I need to find all my 6 trig functions. So the first one I'm going to find is going to be the sine at 3 pi over 2 is going to be?
Negative 1.
How do you find that it goes that way again?
Because it's a positive angle. Positive angles are always counterclockwise. This is going to give you negative 1. What's my cosine? 0. So what's going to be my tangent? Negative 1 divided by 0 is? Undefined. Very good. Okay, so now I'm going to come over here and do I know my other 3 trig functions? Well, what's the inverse of sine? Cosecant of 3 pi over 2. Well, what's the reciprocal of negative 1? Negative 1. So negative secant. Well, that's 0 over 1, so what's going to be the reciprocal of that? No. This is, I'm sorry. sorry, not that. This is 0 over 1. So this is going to make it 1 over 0, which is going to be what? That's fine. Can't divide by 0. Right? What's going to be the cotangent? Well, the tangent was going to be negative 1 over 0, so this is going to be 0 over 1, which gives you 0. Okay, that's last night's homework. Now tonight's homework is going to be 29 through 52 all. Tonight's homework is 29 through 52 all. Your last assignment for the week. Friday? Well, maybe. Today's not Friday. Today's not Thursday. It's only Wednesday. It might not be your last assignment.
Today's Thursday.
No takes back.
I have
Takes back season.
I thought it was.
It's not good.
Okay, 29. The directions say evaluate the trigonometric functions using its period SA. What in the world does that period SA mean again? Why do I need the period SA? Look at the angle 5 pi. Is that on my unit circle? No, it's an angle larger than my unit circle, which is 2 pi, correct? So I need it to fall on my unit circle. So I need to use its period to find its coterminal angle. Okay? So if I want to find its coterminal angle, I need to get a smaller angle than 5 pi. So what am I going to do? I got to subtract 2 pi. So 5 pi minus 2 pi is going to give me 3 pi. Is that on my unit circle yet? My unit circle can't exceed 2 pi. I'm already at 3 pi. So what do I do again? Subtract 2 pi. And what does that give you? Pi. So what you're telling me is the sign at 5 pi is equivalent to the sign at 3 pi, which is equivalent to the sign at pi. Can we understand that? Yes or no?
Yes.
The sign at 5 pi is equivalent to the sign at 3 pi, which is equivalent to the sign at 1 pi. Yes or no?
Yes.
Okay, is pi on my unit circle? Well, it sure is. More importantly, it's over here, and that's going to give me the point -1 comma 0. So what is the sign? It's going to be 0. That's all they're asking for.
Wait.
The cosine of 8 pi over 3. Well, how many pi's are in, with the denominator 3 are in 2 pi? Well, 2 times 3 is 6, so 6 pi over 3 is going to give me 2 pi. Well, is that over 6 pi over 3? Yes, so I know it's not on my unit circle. We understand that. So what do I have to do? Find the coterminal. So the coterminal is going to be 8 pi over 3 minus 2 pi, which is going to be 8 pi over 3 minus 6 pi over 3.
Oh my good gracious.
How did I get the 6 pi over 3? Because 2 pi and 6 pi over 3 are equivalent. So now what's 8 pi minus 6 pi? 2 pi over 3. Is 2 pi over 3 on my unit circle? Yes, it is. So what I'm telling you is I need to think about the cosine at 2 pi over 3 because it is exactly the same as the cosine at 8 pi over 3. So I need to figure out where the cosine at 2 pi over 3 is. Well, first of all, here's going to be pi over 3, and I know according to my clock, the hands on my clock, that this is going to be 1/2 square root of 3 over 2, right? How do I know that? Because it's the denominator of 3, and by the hands of the clock, in quadrant 1, I have the x coordinates 1, 2, and 3. Yes?
Wait,
2 pi over 3,
What?
pi over 3, because all my things, all my fractions with the denominator of 3 have exactly the same sign and cosine value. If I have a denominator of 6, then I'd be looking at pi over 6. If I have a denominator of 4, then I'd be looking at pi over 4. Do you understand that?
Yes.
Okay? Now where's 2 pi over 3 at? Well, here's 3 pi over 3, which means this is going to give me the 2 pi over 3. Yes? quadrant 2. What does that say about quadrant 2? That this is the negative positive quadrant. I'm looking for the cosine. So it's going to be negative. I take my lovely little cosine from my first angle, from my first quadrant, and I just tack on the negative sign to it. Next set of instructions. Evaluate the value, use the value of the trigonometric function to evaluate the indicated functions. So they give you that the sine at t is 1/3. They tell you that the sine at t is 1/3. Now, is sine even or odd? Sine is an odd trig function, which means, remember whenever I drew those pictures, we talked about this? Right here, remember this? I said if you're in quad 1 and in quad 4, remember the positive angles in quad 1, the negative angles in quad 4? The cosines are the same, but the sines are opposites. And if the sines are opposite, that makes them an odd function. Okay? Now, if we go back to what we're talking about right now, it wants you to find out what the sine at negative t is. Well, according to this definition, the sine at negative t is going to be equal to negative the sine at t, because it's an odd function. Do we understand that? The sine at negative t is going to be equal to negative times the sine at t, because it's an odd function. Right? Now, do I know what the sine at t is? What is it? It's 1/3, which means this is going to be negative times 1/3 to give me negative 1/3. That's what the sine at negative t is, by definition of an odd function.
That's all we had to do.
That's all you had to do.
Well, you made it sound crazy.
But you have to understand this definition. You have to be able to know to apply it.
Oh, maybe -3.
Now, the cosecant. Well, what's the cosecant of t? If the sine at t is 1/3, what's the cosecant of t? The reciprocal, which is going to be 3. So what's this going to happen down here? Is the cosecant of t an even or an odd function? It's still going to be odd, which means the cosine at negative t is equal to negative the cosecant of t. Well, what's the cosecant of t? 3. So this is going to be -3.
Wait, how's the cosecant 3? Okay, okay.
Because they're the reciprocal of each other.
Okay.
Hold on.
Let's see. No, not right now.
Okay, 41. 41. Same exact concept, except for this time they tell me that the sine of t is going to be 4/5. Sine of t is 4/5. I want everybody to turn their books to page 'em. Guess I don't see it. Okay, I want you to think about this a minute. It's not in here. If I give you this angle, let's say it's going to be pi/4. Here's pi/4. And if I take, and I'm going to add pi units to that, pi/4, I'm at pi/4, I'm going to add pi units to that. Where's that put me? Across from it, right? It's going to put me down here, right? So if it was plus plus here, now it's going to be minus minus down here. You see that? If your angle is going to be right here, at let's say 3 pi over 4, it was going to be minus plus here. Now you're going to be adding pi to it. It's going to be down here. Now that's going to be at plus minus down here. Do you see what happens whenever you add and subtract pi to your angle? It puts you across from it. Do we all understand that? So if I'm at the sine of t is equal to 4 over 5, now if I take pi from it, what's it going to be at? It's going to be opposite. Do you see that? It's going to simply make that negative 4 over 5 because it's going to be switching the sign going across the quadrants. Yes? Same concept here. What's going to happen? Still going to be negative 4 over 5. And the last set of instructions says use your calculator to evaluate the expression, round your answers to 4 decimal places. Okay, is everybody listening to me on this? You guys need your calculators up so that you can see this to make sure that you have it in the right mode.
Grab one. Good. Secret, you need a map. So do this stuff for you. I said what she was teaching you.
I got it out of time.
You're being a bad friend today.
Full of silence still. I misinterpreted her instructions this way.
Who's the? Ew! Turn around and see who's at the door.
Okay, I want you to be a calculator. Now, when you're up here, you're going to see 2 things. You're going to see battery and you're going to see this little symbol underneath of it. If you click that little symbol, you put your mouse on it. When you put your mouse on it and you hover over that, what is that?
You want to see.
Say no. Do you see whenever you put your mouse over it says angle radius? Angle radius. It is extremely important that you know what mode your calculator is in. Do y'all understand that?
Mine is.
I'm on a calculator page. Okay?
Yeah, angle rad.
Angle rad, that's important. You want it to be in radian mode. Now, whenever you're looking at these things, you have the sine of pi over 6. Literally, what you're going to do is you're going to hit your trig key, and in your trig key, you're going to have all of your lovely little functions. Trig key is to the left of the 7. You want the sine, and then in there, it was going to be pi over 6. Pi is down here. You're going to hit pi, and then divided by 6, and hit enter.
Now.
You're going to get to 0.5. Something we already knew. Now, if you go down and do 47, the cosine of negative 1.7, trig, cosine, and that was going to be negative 1.7. Why is that a decimal? Because it can be. That just means that I was in quad 2, it could be positive 1.7. Okay? Since it's negative, I'm in quad 3. And hit enter. And it gives you a decimal point. Do we all understand that, yes or no? What's the matter, Chad? What
number was that?
Who's chat?
Trig. Trig key to the left of the 7.
Oh.
Trig key to the left of the 7, right here. You see it? Highlighted in red up here. And you simply type it in. Are there any questions over what I'm talking about when using the calculators? If you are not using one of these calculators, and you're using a calculator online, you cannot use the sine inverse or the cosine inverse or the tangent inverse buttons. You have to do 1 divided by the sine. Okay? So if I want to do secant, let's do one that's secant. 51. Secant of 22.8. Hit trig button.
Wow.
Secant, and it was 22.8.
Can you do this on your own?
That's what I'm talking about right now. Now, if you're using a different calculator, please. If you're using a different calculator, hit 1 divided by, what is the opposite of secant? Cosine. So hit your tangent, and you want hit your trig key, and then you're going to hit 1 over cosine, and do the 22.8. And do you see how you get the same thing? Okay?
We don't have to worry about it. We got to use.
If you don't have this calculator, you're going to have to do 1 divided by sine, for cosecant, 1 divided by cosine for secant,
Well, I'm glad I got the calculator. That would
and 1 divided by tangent for cotangent.
I know I'll get 43, 52.
So tonight, you guys need to finish up your homework assignments. I showed you everything that you need to know.
Can you see how many-
Clarifier.
Still have this,
I thought we were working on it.
That's what I thought. I thought we were gonna come across to it.
I was happy to be working on it.
You need